Team noahsmith get a bunch of questions about team name. So it's kind of funny because the guy in this team dropped the class a week later. It's kind of make us short one member, which is okay. But anyway, we're here to talk about our fantastic QA system. The goal of this system is to read a Wikipedia article and generate human-like question from the article and answer a question regarding to the article. It's great, you definitely want to check it out.
In the beginning, we thought about using FrameNet to get computer a better understanding of the content and factoids in articles. So with that said, we can generate and answer questions from those semantic frames. But there's a big concern on the comprehensiveness and accuracy of FrameNet. Let's just say we don't want to complicate the task. So, instead, we're just going to manipulate the syntactic structure of the sentences, and every transformation is by sentence. The first thing we can do is to use Beautiful Soap HTML parser to clean up the input article and parse it into sentence list. And then we have an autograder to give each sentence a score. We can sort sentences by score and start to generate questions from top of the list which we prefer. So we bump the sentences with property that we can use to generate question, and we penalize those we don't like complicated punctuation. Too long sentence might just screw up the transformation. If it's too short, it might be not informative enough. And then we can simplify every sentence we have. Dependent parsing can help us find out which part of the sentence contains the main idea. We also get rid of lexicon that will hurt fluency of questions. For question transformation, we have a bunch of patterns to capture semantic relation within sentence. The most basic pattern is subject auxiliary inversion. Whenever you have a sentence that is composed of a noun phrase and a verb phrase, it implies a factoid that the noun phrase satisfies the following verb phrase. I guess we can see that this kind of pattern directly generates a yes-no question. It also helps us generate identity question, which is coming up. I'm going to give some example about how we generate identity question. So, if there's a person followed by a verb, which we can recognize that with NER, we can ask a who question. If there's any kind of time entity, we can ask a when question. If there's a subordinate clause describing the context of the sentence, we can ask about that, like a why question. By replacing pronouns, we can ask questions too. So there are just more patterns we can play around with before and after inversion. So to generate hard question, our approach is replace word with their synonyms and add-them. We could have done that with WordNet, but it turns out you don't know which definition you're looking for in WordNet, and you don't know if it is going to be a proper substitution, so we just hardcode our heuristic. And we also do things like number sliding. So in the end, we have to check for fluency of the question. If not fluent, just drop it. So we end up with 3 piles of questions, easy, medium, and hard. The first thing we can do is to sort the question by how far they're from the ideal question length. And then we select questions from every pile in a round-robin fashion to make sure we output every type of questions. That is everything about question asking.
Now let's begin the answering part. Co-reference resolution is necessary for many questions. We first parse and split the article into paragraphs. Then do co-reference resolution on each paragraph. 2 components will be replaced. First, pronouns. Second, determiner plus our predefined categories. Finally, we extract original and standard sentence lists from the merged article.
After we get the co-reference resolved sentences, the next step is to turn them into a knowledge database that we can search against. We use the TF-IDF method to do this. This method will transfer each sentence into a vector and assign weights to each of the words. The TF-IDF method will give more weights to words that are more important and more specific to a sentence, and give very small weights to ubiquitous words such as and the. After doing that, we move to process the questions by stemming all the words. Following this is the searching step. We call a sentence which provides information about a given question as the target sentence. Generally, we pick the sentence with the highest TF-IDF score. Although this method will give us the right target sentence in most of the cases, sometimes we find the result is not what we want. To improve our accuracy, we decide to impose more criteria to our target sentence. For example, if we detect that a question is asking about a time, we require the target sentence to contain at least one phrase related to a particular time. If a sentence contains no such phrase, we will not pick it, even if it has the highest TF-IDF score. Similarly, for questions asking about a quantity, we require the target sentence to contain phrases related to a number. After we pick up the target sentence, for WH questions, we just output the whole sentence. However, for yes or no questions, we need to be more careful to give a definite yes or no answer. To do that, we first tag each word in the question sentence with post tags and define keywords according to the tags. After getting the keywords, we try to find all the keywords in the target sentence. But we know things are far more complex than this because we need to consider synonyms, antonyms, and negation words. To do this, we extract all the available synonyms and antonyms from the WordNet and compare them. Only if all the keywords or their synonyms appear in the target sentence, we answer yes. Otherwise, if we find missing keywords, antonyms, or negation words, we say no. In practice, in addition to the synonyms and antonyms given by the SynNet, we also build our own customized synonym and antonym dictionaries to improve accuracy.
Hey, so that's our system. The answer accuracy to question that human generated is about 75%, and to this question that our system generated is about 90%, which is pretty great. I hope you enjoy playing around with the system. Thank you.